We proceed to the third functional group, which is alkenes. Alkenes have the general formula of CnH2n, and in the structure of alkene, it must at least contain one carbon-carbon double bond. Alkenes are also called as olefins, and they are part of homologous series. And the fourth functional group is alkynes. Alkynes have the general formula of CnH2n-2. Alkynes contain at least one carbon-carbon triple bond. Like alkanes and alkenes, alkynes are also part of homologous series. So the difference between alkenes and alkynes, alkene has double bond, while alkynes has triple bond. For these two functional groups, the root name is determined by the number of carbon atoms in the longest carbon chain that also contain the double bond for alkene and triple bond for alkyne. The carbon chain is numbered from the end closest to the multiple bond, and the suffix for alkene is ene, and the suffix for alkyne is yne. Alkenes and alkynes are named in the same way as alkanes with the following exceptions. The base chain is the longest continuous carbon chain that contains the double or triple bond. The base name has the ending ene for alkenes and yne for alkynes. The base chain is numbered to give the double or triple bond the lowest possible number, and a number indicating the position of the double or triple bond is inserted just before the base name. So that's the rule in naming alkene and alkynes. Let's look at this example. First step that you need to do is to find the longest carbon chain. But for alkene and alkyne, you need to make sure the longest carbon chain must contain the double or the triple bond. So for example, if we pick this one as the longest carbon chain, it has 9 carbons. But if we choose this one, the longest carbon chain has 8 carbons. However, since it contains the double bond, so we will pick this one as the longest carbon chain because it is important to have the double bond in the longest carbon chain for alkene. So the others would become the substituent. So this will be the substituent, and the other two also the substituent. So there are 3 substituents. This is ethyl, and these two are propyl. And then for alkene, you also need to give number at which carbon is the double bond located. So when you want to number the longest carbon chain, you need to make sure that the location of the double bond is the smallest as possible. So your priority now is the double or the triple bond. So this one we will start number it from this top. 1, 2, 3, 4, 5, 6, 7, 8. And since there are 2 types of substituent, so we need to name it alphabetically order. So we will name ethyl first. So ethyl is placed in the second carbon. So the name would be 2-ethyl 4,5-dipropyl, since there are 2 propyl, and then dash 1-octene. Because the double bond is at the first carbon, so the number is 1-octene. So that is how you name alkene. Another example here. This one, it contains 2 double bond. You need to count the carbon from the end closest to the double bond. So we need to start count from the right side. 1, 2, 3, 4, 5, and 6. And in this structure, there are 2 double bonds. Since there are 2 double bonds, you need to add prefix of di, tri, etc. where appropriate. Since there are 2, we need to use di. Hence, the name of this compound is 1,3-hexadiene because the double bond is placed at first and the third carbon. Di, the prefix will be added here in between hexa and ene. Next, you can try this exercise. Try to name these two compounds. One is alkene and the other one is alkyne. Another exercise for you. From the condensed structure, you need to draw the expanded structure and then give the correct IUPAC name. And another exercise, this one also you need to draw the expanded structure from the given IUPAC name. So for this one, I'll give you an example for question number 1. So how to draw it? First, you need to identify the root name. Hexane, it contains 6 carbon in the longest carbon chain. And then you look at the substituent. So here we have two substituents, dimethyl, and this 2-methyl is located at carbon number 2 and carbon number 4. So we need to add 1 CH3, and at the carbon number 4, we need to draw another methyl. And for the rest of the carbon, you need to add hydrogen. So this is the structure for 2,4-dimethylhexane. You can try question number 2 by yourself. Another exercise given here. You are given an incorrect IUPAC name. Determine the correct IUPAC name. From the incorrect IUPAC name, first thing that you need to do is to draw the expanded structure and then try to name it correctly according to the rules that we have learned. So that's the end for this topic. I hope you understand. Thank you for watching.